Good afternoon. Welcome to lecture 139 140 for the course Thermodynamics of Materials. We are discussing assignment number 11. Last class we have solved problem 1. So we will actually solve 9 problems, 1 already over. So 8 problems remaining. Let us see how many problems we can solve. So I have actually given the 3 problems here. 2, 3, problem 2, problem 3, problem 4 I've already written beforehand, so that actually we can save some time. But still I will read this problem. Start with problem 2. Is what? Initially pure metallic iron is melted in a silica crucible at 1900 Kelvin. The crucible and contents are brought to equilibrium with a gas consisting of 99.3% CO and the rest CO2. P total is 1 atmosphere. Calculate the weight % dissolved oxygen, carbon and silicon in the iron, assuming that the small amount of dissolved solutes do not affect each other's activity coefficient. Means this implication is that you consider only self interaction coefficient, don't have to consider the ternary interaction coefficient. This is actually some simplification. You just don't have to come every 10 minutes or 5 minutes. Okay. 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 It looks okay. So so with this we'll move on to problem 2 solution. Problem 2 solution. I may draw a sketch here. This silica crucible, you have. So let us draw a line here so that there is no actually mixing up here. So crucible is this is the silica crucible. Your iron is there and gas is what you have here. Okay, wait a bit. Let us. Okay, wait a bit. Iron liquid. We have a gas mixture. CO, CO2 and oxygen negligible. Okay, this is temperature 1900 Kelvin. oxygen will be negligible. We'll show this CO, CO2. 99.3% CO and balance is CO2. So this is given to you. So let us solve this. Let us take up the data first. Okay, the carbon graphite. This data are given. Data given. Either data will be given, assorted data will be given, or you have to refer to books, data book. Okay, Gaskell's textbook gives the data, and this data, and you can Tagdogan's book, or you see it is Elliot, Gazar and Ramakrishna data book. So host of data books. Okay, this is let us write it out. Carbon graphite plus half O2 oxygen goes to CO gas. Delta G0 is minus 114,390 minus 85.77 T joule is one data. Another is, let us start this side. C graphite plus oxygen gas is CO2 gas. Delta G0 is minus 395,346 minus 0.54 T joule. What you will get? You will have actually, you have to find the dissolve all these things. So if you combine this and manipulate these two, you have CO2 gas, CO gas rather, CO gas plus half O2 gas goes to CO2. Actually, I have taken these two data from Gaskell's book, Gaskell textbook. So this is delta G0. Actually, I have got this problem from the problem manual. Actually, this problem manual, actually, it was not, name of the author was not written, but I guessed from the reference of Gaskell's book that this must be A.E. Morris. Actually, this manual I got from Professor Gaskell when I was doing PhD with him. So this only the problem. Problem manual contains only this much. The data was not actually accompanying it. So I got the data, collected the data from this, or sometimes from Tagdogan's book. Tagdogan textbook, high temperature, physical chemistry of high temperature technology. Okay. Sometimes from okay, these two mainly. So anyway, delta G0 is minus Janov table is that you can refer to that also. So that is very reliable. But anyway, minus 280,956 plus 85.23 T joule. This is okay. Now delta G0 1900 is what? 1900 is what you will get from this delta G 1900 is minus 1,19019 joule as usual. This gives you a equilibrium constant. K 1900 is what? 1871.78145 is what? Very simple. These are all activity of gases are partial pressures. PCO2 over PCO by PO2 power half. PCO is how much? Total pressure 1. So PCO is 99.3 means 99.3% means mole fraction is 0.993 and partial pressure is mole fraction times total pressure, which is 1 atmosphere, so it is 0.993, very easy. And PCO2 would be how much? The balance is 0.007. 0.007. So then you get or PO2 powered half is 3.77 times 10 to the power minus 6, or PO2 is how much? Or PO2 is 1.42 times 10 to the power minus 11. Okay, this is atmosphere. So this is negligible, small, negligible. So this we already mentioned. The oxygen is there. This PO2 of a gas mixture, this PO2 is called oxygen potential. You know this, equilibrium PO2. But these are typically very small values, but these are very important. Oxygen potential governs the driving force for reactions, or say in relative values of oxygen potential decides which way the reaction will go. Okay, this you remember in Henrian diagram this was used, and this concept of oxygen potential, but this is very small when compared to total pressure 1 atmosphere. So this is one thing, but even so you will soon see the oxygen percent that you will calculate will be obtained from this PO2. Although small, 8% oxygen will also be accompanying oxygen will be also small. So iron liquid, what it contains also from silica iron liquid is better I write here. Iron liquid, it will pick up silicon, it will pick up carbon, it will pick up oxygen. Oxygen will be very small, but that small value is required. And in fact, small oxygen is actually deleterious for steel. You know, strainaging phenomenon, all the mechanical properties affect oxygen, nitrogen, gases. Okay, so this small value is also important. So we ignore this PO2 when it is compared with the total pressure, or when you sum PCO plus PCO2, which are finite values, plus PO2, which is small, we ignore that. In the additive terms, in the summation we ignore, but by itself don't ignore, because it gives rise to some 8% oxygen, which we will calculate now, and that oxygen in steel is serious issue. Okay, so anyway, let us discuss this thermodynamic, this problem. 8% oxygen will be what? Which equilibrium will consider? Remember, so half O2 gas. Next consider half O2 gas goes to, okay, is okay. You save this PO2 value. Okay, 10 to the minus 11. Very good. Okay, very good. Half O2 gas goes to, it's too much, na, to close. Next, consider half O2 gas goes to oxygen, again 8% Henrian standard state, liquid iron. You can give an underscore here, or you may not. Okay, this is Henrian. Again, remember, this is Henrian standard state, and this is Raoultian standard state. No problem. So delta G0 is given. What is the value of delta G0? Shall I write this side? Do I have delta G0 is what? Delta G0 is what? Minus, okay, 1. Let us see if I can write 1,1,1,300. Yes, 1,1,1,3 minus 6.41 T joule, from which you get delta G0, again the temperature being 1900, you find out delta G0 1900 will be minus 123,479 joule, from which you will again get K equilibrium constant. Recall delta G0 is minus RTL and K. So okay, K 1900 delta G0 is minus, I should have written here. I write it actually at the top here. This first case I write, so that you should remember that delta G0 is minus RT ln K. So from which you get K. This you know, but I am mentioning this point here. Is what here also similarly delta G0 is minus RT ln K, and K is what? Is what K will be? K 1900 will be this. Give this temperature, specify the temperature, very important. Equilibrium constant is a function of temperature, so don't forget. 1900 is what? 1871.35. 1817.145. This is what you write again, expression, equilibrium constant expression, right? This is given in, remember, these are the standard states and this delta G0. G0 of this minus G0 of this is given. About a physical state, read the problem. Physical state, read the problem and see the problem here. You have a problem or the sketch that you have made. That is this one. This problem is sketched here. So see here, which physical, don't see the physical state here. Okay, see here. And what these are merely the standard state. This is required, and then that will be used while in the equilibrium constant expression, activity of this oxygen with respect to the standard state. This standard state activity requires a standard state, and equilibrium constant expression contains activity in the product and reactant. So activity of product here, what symbol you will use? Henrian activity, HO, because this is Henrian standard state, and this is Raoultian standard state. So as usual, PO2 power half, and HO, since Henrian activity, two types, weight percent and mole fraction. Weight percent we will use. We are using for all problems weight percent. Okay, HO weight percent is what? We continue. Is continue here. What is HO weight percent? Tell me. Your aim is weight percent oxygen. So HO is what? FO. FO actually you should FO times FO weight percent oxygen. HI is FI weight percent. Okay, very good. PO2 power half. About FO, okay. FO actually FO again I am writing FO 8%. This is Henrian activity coefficient. So log, so since actually FO 8%, as yesterday I told you that FO 8% and FO mole fraction same, so only one, you don't give any subscript here, just FO. What is the expression for FO? Maclaurin's, what is this called? This called Wagner's E formalism, or E, just E, not epsilon, log, since log FO is what? EO weight percent oxygen plus what other solutes are to solutes. Solvent is iron. Solute is what? Next is silicon. Weight percent silicon plus, you write here, don't disturb this place, plus EO silicon, weight percent silicon plus EO carbon, weight percent carbon. Okay, this is a quaternary system, three terms, iron being the solvent. So of this, I tell you what, these two are this is given that the other solutes will not affect the activity coefficient. So oxygen's activity will not be affected by the others, each other. Means here these are small amount, do not affect. Okay, is 0, these are 0. Why 0? As given. Okay, what is this? Ignoring the right, ignoring the effect of other solutes, namely silicon and carbon, as instructed, as instructed. Now here weight percent, here this is, EO is, this is also, so right, so it is actually EOO, weight percent oxygen. Now weight percent oxygen is small, very small, serious issue, serious, okay, serious for our, okay, for our okay, steel composition, for the use of steel, for the properties of steel, but small. This value is small. Okay, EO, weight percent oxygen is small. Give here weight percent oxygen small, will be, as we will see, will be, this will be small. I am considering small will be, to justify later. This will be justified later. To justify later. Why that it is small? We don't know yet. We don't know yet. We are going to find it, but we will see that it is coming small. Okay, so this is standard technique. If you consider small and then you check back weight percent oxygen. If it is small, then whole thing is small and negligible, is 0. This small weight percent oxygen. This is actually we are going to find. So once, so log FO is 0, or FO is what? 1. Okay, it is 1. Okay, FO is 1. Okay, approximately 1. Right, FO is, log FO is 0, FO is 1. So this will be 1. So what you are getting? Weight percent oxygen. You can always write equilibrium if you like. If you like here, equilibrium, at equilibrium, since it is related to equilibrium constant. So weight percent oxygen over what is the PO2? Power half, 3.77 times 10 to the minus 6. That gives you, weight percent oxygen is how much? If you calculate this times this is actually weight percent oxygen 9.36. 9.36 times 10 to the minus 3. This is the weight percent oxygen. You have one answer, weight percent oxygen. And this is a small quantity, you admit. This is a small quantity, less than 0.01, small. So to justify it, justified. Small, and justify the assumption that it is small. Okay, justified. Just I am writing justified. We assume something that will be justified later. Now it is justified. Yes, it is small, no doubt. So if you have this value and multiply this, it will be very small, and we may consider this is 0, almost 0. So we have ignored this part, and these two terms, the problem is, according to the problem, these two are to be ignored. Don't have, these are only consider self. Don't consider the ternary, this ternary or this ternary. Okay. Effect of silicon on oxygen, effect of carbon on oxygen, means activity on activity coefficient of oxygen, effect of silicon on the activity coefficient of oxygen are to be ignored, and only this remains. But incidentally, this is also very small. So FO is 1. FO 1 means this is out, disappears, as if HO becomes weight percent. HO becomes weight percent. The simplest. Okay. So we'll consider when this activity, Henrian activity coefficient is 1 or close to 1, then HO is a weight percent too. So this is answer. This is also, since this is so very small quantity, we use the term ppm also in, we can write also in ppm. What is the ppm? This is this, so this part 9.36 times 10 to the power minus 3 parts per 100 parts. Percent means per 100 parts. What is ppm? Per million parts. So you have to multiply divided by 100 times 10 to the power 6. So this is actually 9.36 times 10 to the power minus 3 divided by 100. Percentage means per 100 part, and then what is the per million? So this always becomes times 10 to the power 4. This is, and if you do that 10 to the power 4, it will be 93.6 ppm. This is what we often do in case of oxygen, sulfur, phosphorus in terms of ppm. 0.02% means 200 ppm. You multiply by 10 to the power 4. Okay, so this I will do, okay, when we will come across very small concentration. This one is the answer. But next is what? Next is what? Wait, what is remaining? Still remaining? Carbon and silicon. Weight percent carbon and silicon. So let us take up the silicon. The way I have solved this, silicon take up next. Next, silicon is what? What equilibrium we consider? Tell me, silicon. Next, consider the equilibrium is what? Silicon, again 1 weight percent in liquid iron plus O2 gas goes to SiO2 solid. SiO2 solid we are considering because this is a silica crucible. Crucible means solid. So this is your oxygen gas. Again, you see, this is Raoultian standard state. You don't have to write, but just I am pointing out this. This is Raoultian standard state and this is Henrian standard state. Anyway, get delta G0 is given to you. Data given, okay. Data given, okay. Right somewhere. Data given. Data given. Delta G0 is what? Minus 833,400 plus 229.5 T. Remember, this part is delta H0. This is minus T delta H0. Okay. This looks out. It's okay. This is in a field. It's okay. Okay. No problem. It looks normal. Okay. Now delta G0. So what you will proceed? How will proceed? Get the equilibrium constant. How? Find delta G0 at the temperature of experiment. 1900 is what? Delta G 1900. If you do this, minus 397350, minus 397350 joule, from which you will get equilibrium constant. Delta G0 is minus RT ln K. Remember always equilibrium constant K 1900 is what? How much it is? K 8.4 times 10 to the power 10. 8, sorry, 8.4 times 10 to the power 10, huge value, because this is very large negative. Accordingly, equilibrium constant minus R T ln K. So negative large, and there is a minus there, so it is large positive. Large high value 10 to the power 10 is what? Right nicely. The equilibrium constant expression. See the reaction. Silica solid. Silica solid. So since Raoultian ASiO2, and this is okay. I am coming to this. Take up. This is Henrian H SI weight percent. Happy, and then it is oxygen as gas. It is Raoultian, but it is activity is nothing but partial pressure of oxygen. And again, if you are interested, or if you are interested, or you may, I should recommend the right equilibrium, at least write once that it is under equilibrium. What is the activity of SiO2? SiO2, this is with respect to solid. This is the standard state with respect to solid. This is this SiO2, the crucible SiO2. This physical state is solid, and with respect to solid standard state, so this is pure silica. This is pure silica, and its activity is pure silica. Not only pure silica, solid silica, because it is the, and in the crucible it is solid silica. So this is one. What else? Or HSI. HSI would be what? As I keep on writing, is 1 over HSI is again FSI times weight percent SI. Always Henrian activity coefficient times weight percent, okay, times PO2. What is the value of PO2? PO2 already you got somewhere where this is 1.42 times 10 to the power 11. PO2 is where? Yeah, 1.42 times 10 to the power minus 11. Sorry, minus. And as a result of which, what you will get here? It is better you write HSI. You keep writing. This you will write later on. HSI. Retain this. HSI weight percent. HSI 8%. Give a star from this place, and I think I can remove first two lines easily, very easily. Very easily. What is HSI at weight percent is what? Star this. Star HSI weight percent is how much it is coming. If you do this calculation, HSI weight percent will be, as I tell you, 0.84. Just simple 0.84. Okay. Now actually wait a minute. Keep it. This is okay. Now if you consider that HSI is weight percent silicon, means if now HSI weight percent is what? Tell me. FSI times weight percent silicon. Now sometimes we consider that this follows actually these values, Henrian activity coefficient is small. So small means 1. Okay, log is like this. FO is 1. So so that HSI is weight percent silicon. This is an approximation we sometimes do. Considering this value is 1, or log of this is 0. When this comes, because when this interaction values do not contribute much, this total contribution is almost negligible. Total. Okay. Particularly at low concentration, if these are low, very low, then they will be, each will be close to 1, close to 0, and sum total will be 0, and these log FO will be 0 and FO will be 1. So given this, if you assume that, make that approximation, then what is your answer? HSI is weight percent silicon, then weight percent silicon will be 0.84 answer. If you consider that FSI is 1, then this is the weight percent silicon at equilibrium, and this is the answer. But let us see what would happen if we don't ignore FSI. Rather, we will find out for refined calculation, for precise answer. What this we don't want to approximate. Okay, we don't consider this. Let us try to find out what is the value of FSI. What is this? As you know, log FSI is what? Now, log FSI is what? As you know, this is actually Wagner's formalism we are using. Tell me first is self interaction, weight percent silicon. And again, I am writing these two, but these two are writing silicon effect of carbon, weight percent carbon plus oxygen, weight percent oxygen. These, incidentally, these are ignored. These effects are ignored as per instruction. Inside they are in place. Others will not affect, means effect of the other solutes. Okay, will not uh, is not okay. Uh, it's not much, so you can ignore this. Ignore as per instruction, as per the problem. So, so any don't affect that. So these are called ternary interaction coefficients. So, so what you have? Only the self. Self. Let us find the value of self. Self is what? ESI is this data is actually we have this data. ESI 0.32. I'm writing here so that you don't have any doubt. This is data given. This is given. The data is given, or you will find it for yourself. So 0.32 weight percent silicon log SI. So now you try to find out this. Okay. So write this. From this what you get, take a log. To make use of log FSI, you try to get the log of this expression. Log HSI, weight percent is what? Log FSI plus log weight percent silicon. Remove the next line also. Remove this. Okay. Then what it is? Log HSI, or what this? Log HSI is 0. So write this out, 0.84. Log FSI is what? This. If you had considered this, then you have more terms. In a different problem, in a subsequent problem, you will see there are more terms. But here, since this simplification is allowed, so this is only one term. But anyway, still it is there. It is not 0. Okay. So what it is? 0.32 weight percent silicon plus log weight percent silicon. Again, you note this is actually log 0.84 is how much? Log 0.84 is minus, this is minus 0.076. So you solve for weight percent silicon. Difficult because this is nonlinear, but after all, this is actually one unknown, one equation. Weight percent silicon is unknown, one unknown, one equation. We can solve by trial and error. Okay, solve for trial and error, or what you call iterative method. Iterative method. Here actually is how we proceed. You actually to starting value would be what? You suppress this term, get what weight percent silicon, then put it back into this and treat it. I'm sorry, here. Then put it back into this term and find out weight percent silicon what value. This will be a different value. Then again try that value, this next value, with again substitute here and again find out weight percent silicon. Every time it is updating all the time. This is called iterative method. And later on you will see the values are converting to a given value, and that is the answer. This is, perhaps there are other methods of solution, but this method solve for, and if you solve, then weight percent silicon, solve for by this weight percent silicon. If you do this, answer is what? 0.55. 0.55 weight percent silicon is present. Answer. Even answer. So now see the difference. If you had considered this as the weight percent silicon, means ignore FSI, then HSI is 8% silicon. Then this would be the answer, but actual answer is 0.55. So there is huge difference. Huge difference. So this shows the importance of considering this equation, this expression for APSI, which is Wagner's E formulation. Okay, the relation between APSI and weight percent or concentration terms. Okay, and involving the interaction coefficients. These are the importance of this. Okay, so this is, so you mean write down one line here to the importance. So see 0.84 weight % silicon is 0.84 would be wrong. Would be wrong. Why? Because you consider a weight % would be wrong. This is the answer. This is the right answer. Okay, so you can write this. Then this shows this change. This change in result, if I may write from, for approximation, 0.84 approximation, from 0.84 to what actual, what more refined value, more correct value, to 0.55. This change in result and gives this change in result shows the this change in result shows the importance shows shows the importance of giving due, shows importance of giving due sorry, shows the importance of giving to the Henrian divisible Henry's law. Okay. The importance of considering HI is FI, HI weight %, FI prime weight % I. Okay, that is not. Acha, this change in result shows the importance of not ignoring. Okay, importance of not ignoring value of the term APSI, Henrian activity coefficient. Henrian activity coefficient. This is a demonstration. You may say, sir, if you don't ignore, yes, it will be even more correct. Even more correct. Sometimes we simplify a problem to see if the students can solve the problem. The simplified form of the problem can solve. Understand? If you can solve this, considering this 0, if you can solve to this point, then you understand the problem. Then you can easily add this. This is more of mathematics. Okay, no problem, no big deal. Okay, plus, not difficult. Okay, So you have noted this change in result from, okay, this shows the importance of not ignoring the term FSI as 1. You ignore, when you ignore means, if you ignore means you are considering 1. And log of that, log SI, FSI is, you are considering 0. Why it is 0? These terms are these interactions are negligible, small, 0. So log FSI is 0, FSI is 1, but they are not actually 0. There are certain values, and you see this clearly shows that it is, the answer changes from 0.84 to 0.55. We know how much it, okay, how much it signifies that, okay, silicon percentage changes from 0.84 to 0.55. It's big deal. So serious, what remains, still remains. I remove this. This problem is not yet over. So what is the last one? Silicon is over, or carbon? For carbon, what equilibrium you consider? For carbon, similarly, now carbon, okay, weight percent carbon. Next, 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 weight percent carbon. So again suitably consider this equilibrium. Okay, this one, this is what? Carbon, graphite plus half O2 gas goes to CO gas. This data, right here, data means data either will be given to you, or you will be given actually assorted data. You give a whole list of data. A data, okay, couple of pages, runs couple of pages. You find out which is useful for you, or go to the data book. C plus half to CO gas, again delta G0 is what? You know, this is already used. Is what? Repeat that. Some data will be repeated. 114,390 minus 85.77 T joule. Okay, this is C. Then another one you will do what? Now C, 1 weight percent in liquid iron. Iron goes to, and C graphite. GR means graphite, solid as graphite. Delta G, not diamond. Delta G0 is what? Minus 22,594 plus 42.26 T. Recall, there is 5 topics, 5 issues. B1, how to get this? C graphite to carbon weight percent in the form of delta G0 is A plus BT. These two, this left hand side, this right hand side means the opposite sign here. I showed you how to get this value, how experimentally you can, how you can find. Experiment, CO2 gas flowing over a liquid iron. Remember this, so but this is the data, okay. These are picked up from data book, no problem, okay. So then what you write? You combine, etc., combine properly, you get carbon, oh sorry, you write here, carbon 1 weight percent in liquid iron goes to, I'm sorry, plus half O2 gas goes to CO gas. What is the delta G0? You write this minus 136,984 minus 136,984. Then what else? Minus 43.51 T joule. Okay. Again, similarly, delta G0 900, 1900. Temperature is 1900. 1900 is what? Minus 219,653 joule gives you K equilibrium constant 1900. Using delta G0 is minus 3 ln K. Okay, is what? 1093704. 1093704. So 93704 is what now expression for equilibrium constant. This is a bit of challenge or easy, but you are used to this. What is assignment 7? This is in a sense assignment 7, but all accepting this 108% standard states. Okay. Okay, what is this right here? Product PCO. Since gas, again this is Raoultian, this is Henrian. Okay, I'm not writing this, you understand. This is Raoultian, this is Henrian. Raoultian means gas also, gas phase. So standard state is 1 atmosphere. So PCO over what is this? HC, you know very well, HCO 8% times what is PO2 power half. You recall these values, PCO is okay, you know, substitute this value. What is PCO? 0.993. You know this values is given here, 0.993, 99.3%. This I have used already, and PO2 power half is how much? Is it synced here? I have removed this, perhaps. I have removed this, but the value, you recall this value is PO2 3.77 times 10 to the minus 6. 3.77 times 10 to the minus 6 already found. Okay, I will remove this. Okay, or what you get out of this, or HC weight percent, HC weight percent is how much? HC weight percent is how much? Is what? 0.24. Now this is, yeah, okay, we'll get this HC is, or HC is what? FC times weight percent, FC times weight percent is 0.24, or log FC plus log weight per, oh sorry, weight percent what? Weight percent what? Carbon. Very sorry. This is HC weight percent Henrian standard state is what? Henrian activity coefficient times weight percent carbon. Okay. So FC times weight percent, okay, carbon. I'll take a log on this, log FC plus log, take a log not ln, log for Henrian activity coefficient, okay, and that is also Wagner's formalism. Log FC plus log weight percent carbon is log 0.24. Log 0.24 would be what? Log 0.24 would be what? Minus 0.62. Minus 0.62. Or continue. Or what is log FC? Log FC is what? Tell me. ECC log FC, you know, ECC weight percent carbon plus you will not write. The others are already considered or advised or suggested to be negligible. Okay, they have these two terms are considered. And this shall I write here? Next one is what? EC silicon weight percent silicon, EC oxygen. You write for full, but these two to ignore as per problem. Advised, the problem has advised to ignore these other solutes except the self one. Okay, these are called ternary. Okay, the other solutes, namely silicon and oxygen. Effect on carbon, but this is effect of carbon on carbon. So self interaction coefficient. So ignore is what? Log FC. This is log FC expression plus log weight percent carbon plus log weight percent carbon is minus 0.62. I should write this at the top two lines I remove, and this is give a star here, again star. So if you write this nicely, again write ECC weight percent carbon, these are out, plus log weight percent carbon is what? Minus is minus 0.62. This is, remember, this is minus 0.62. Minus 0.62. Well, because log of a decimal quantity is a negative quantity, okay, is minus 0.62. And what is ECC? ECC is how much? It is given to you already. ECC is what? 0.22. 0.22. Or you write once more, 0.22 weight% carbon plus log weight% carbon is minus 0.62, and again solve as we one unknown, one equation, solve for weight% carbon, trial and error, solve for weight% carbon, solving for weight% carbon, what you get? Weight% carbon is this, you actually can check back, this is 0.215, this is your answer, 0.215. So now answer. So three answers. Silicon is where? Silicon already I have removed this, but silicon. This is answer. Oxygen answer and carbon. So list these three stuff. Give as desired. So answer is this. Hence, write weight% oxygen. Write nicely. Weight% oxygen is 9.36 times 10 to the power minus 3 already. Okay, see, you know this. Weight% silicon is how much? Here 0.55. This 0.55. And last is weight% carbon, 0.215. This is the answer. So problem 1 is over. Problem 2, sorry. Problem 2 is over. So remove this. Problem 3, we consider this. Solution 3. Alright, problem 3 solution. Okay, solution of problem 3. Problem 3. What is this? Let's read this. During the last stage is in oxygen blowing in BOF steel making, basic oxygen furnace steel making, about 85% of the oxygen goes to oxidize carbon to mostly carbon monoxide, and the rest oxidizes iron to FeO in the slag. Assume the oxygen used contains 1% nitrogen. Calculate the 8% dissolved nitrogen in equilibrium with the gas produced by the above blowing condition. Temperature given as 1873 Kelvin. Okay. So this, let me draw the figure. First of all, a sketch will be helpful. It may be given this way. This is your, okay, and what is there? It is here iron, carbon, nitrogen, liquid iron means metal phase. Sorry, everything is liquid, metal. Then you have slag phase, slag, FeO and others, like say, I tell you what others, slag phase. And then you have the gas exiting, the gas that contains CO nitrogen, exit gas CO plus nitrogen. These are exiting. P total is 1 atmosphere. Why? The reason is open to atmosphere. top is open to atmosphere, system is open to atmosphere, open to atmosphere, open to atmosphere. This is CO nitrogen. And what else? Yeah, you are blowing here. What? Oxygen plus nitrogen. Oxygen is 99%. This is 1%. This is your problem. Weight per question is what? Question is what? Weight percent. Question: weight percent nitrogen in liquid metal, in liquid iron. Okay, in the liquid phase is how much? Question is what? What is calculated the weight percent dissolved nitrogen in equilibrium with the gas. Okay, this is your. What is the other? This metal phase is clear here because you are passing this and carbon. It is already said. It is accepted that it is okay. Given that carbon is oxidized to CO, so carbon is present here in the metal phase. So carbon must be there, and since nitrogen is entering, so nitrogen, for nitrogen there will be some dissolved nitrogen. So these three metal, and your slag is this. Okay, iron, a partly this oxygen, part of the oxygen, 15% of the oxygen will oxidize iron. Obviously, iron oxide. Somehow iron is always lost because of oxygen blowing. Okay, you cannot avoid this. So APO, but the main ingredient of the slag is not APO, of course. The basic is a basic process, basic calcium oxide, lime. So lime is there, so etc. But we don't care. Our interest is not that. Okay, what I will use this. In fact, slag is not participating in the equilibrium. Is not considered in the equilibrium. It is the whole thing is at equilibrium. This is the equilibrium state after all. Okay, because written was somewhere at equilibrium. See, in equilibrium. That means when the gas is blowing here, blowing into this, reaction takes place, slag forms, and gas exits. This before leaving, it is coming. The gas is coming. Is attaining equilibrium. Okay, coming to equilibrium with respect to all these three. This whole thing: gas, slag, liquid, gas, slag, metal, liquid. I'm sorry, metal. Slag is also liquid. Gas, slag, metal, equilibrium. And this is in the bottom blow. This actually we expect that this is much easier to achieve than LD steel making. But these other issues start the problem. Okay, let us consider. Start. Let's consider n mole oxygen plus nitrogen is blown. N moles. Okay, that means what does it mean? Okay, is blown. Hence, so n moles 99% means 0.99 n moles total, right here. Oxygen plus nitrogen blowing into this. So 0.99 n oxygen moles oxygen and 0.01 n moles nitrogen. Okay. Now of this oxygen, 85% is actually doing oxidizing C to CO. So 85% of this, okay, for 85% of this is doing what? Oxidizing carbon to CO. Okay, carbon mostly to CO means CO or a little bit of CO2, but this is instructed that don't consider CO2. Simplify CO. Okay, but it should be CO2 also. Okay, although main predominant gas is CO. Okay, so 0.99 mole CO. So what you shall I write here? Okay, shall I write here? 0.99 mole CO is what? Actually, I should have written here 0.99 moles, of which 85% means 0.85 into 0.85 is how much? is 0.84 N, 0.84 N mole. Mole, what it is this? Mole O2. Mole O2. What it does? Oxidizes. Shall I? Actually, I am writing here. It is very bad here. Let's start this. This 0.99 mole here. Just there is a bifurcation. What is this? 85% of this is, which is nothing but 0.84. Also, I am writing this 0.99 quickly. 0.99 times 84%, 85% is 0.84 mole oxygen utilized to oxidize CO, oxidize C, oxidize C to CO, and what else? 0.84 out of 0.99. So remaining 15% is what? 0.15 mole. Remaining 0.15 mole O2. Okay, that's a 15%. 15% of this is 0.15. Okay, total is 0.99. So mole O2 utilized to oxidize Fe into FeO, to oxidize here is C into CO into, write better, CO, to oxidize C into CO. Okay, so if this is this, then you follow this. So you have gas. This is all. This is FeO is actually liquid component. So gas is what here? Gaseous species is what? Point. So actually, okay. What are the gases? C plus half O2. Follow that reaction. If 0.84 mole O2, 0.84 mole O2 produces, oxidizes, right? Oxidizes carbon to produce how many mole? How many mole of CO? Oxygen twice as much. So 1.68 mole CO. One important issue. Okay, 0.84 mole. So how many moles you are getting then? Oh, we have made a mistake here. 0.99 N is here. Oh, sorry. Very bad. N. 0.99 N. 0.84 N mole O2. 0.15, 0.184 N and mole O2. Mole O2 utilized. Okay. So 0.84 N mole O2 oxidizes to produce 1.68 N. So the gas composition. So we have the exit gas contains what? 1.68. Sorry. 1.68 N mole CO, and how many mole of oxygen, nitrogen? 0.0. Here. See the breakup. This is the first breakup. Then this is further broken into two parts. One of them is gas, another is product is CO gas, another product is FeO. So it doesn't contribute towards the gas moles. So this is out. So what you have? This 1.689 mole of CO and 0.01 mole which is not reacting, unreacted mole nitrogen. So inert. This is the exit gas here. CO. What is the problem? CO plus nitrogen. CO plus nitrogen. Okay. Now you may argue that sir, oxygen reoxidizes, but is is there no oxygen left over at equilibrium? Left over or unreacted? So all equilibrium means there is some unreacted. Yes, there is. But this equilibrium constant is very large, so negligible. So O2 will be negligible, totally, fully converted into CO. That's full, negligible it will be. So if it is negligible, there is no oxygen also. You might say as oxygen is all there, oxygen potential is there. This is negligible, as I say. As when you combine, then there is nothing. Okay. So what is the thing is this? What is the partial pressure of nitrogen in the exit gas? PM2, hence PM2 into exit gas. Tell me what is this value? Tell me, is nothing but 0.01 N by total is how much? 1.69 N times the P total. What is the P total? Given here 1 atmosphere, open to atmosphere. So how much it is? If you do this, Pn2 is what? Nn cancel. So it is 0.01 by 1.69, P2 5.92 times 10 to the minus 3. 5.92 times 10 to the minus 3. This is the Pn2 atmosphere. But this is not the question. So this N2, Pn2 in the exit gas, which is in equilibrium with all this, is what? This much. Very small though, but anyway, nitrogen solubility will be, dissolved nitrogen will be small. And that small value is also, okay, that strain aging phenomenon, small will do havoc. So will be deleterious. So this is okay. So this is a nitrogen gas. So what is question is what? 8% nitrogen dissolved. 8% nitrogen. It is not the atmosphere. So 8% nitrogen. So what you will do? Give a star here and continue here. Only here. Okay. So 8% nitrogen is the question. So continue to consider the equilibrium between C what and what? See here, nitrogen gas. Nitrogen gas and nitrogen. That's these two. Everything is in equilibrium. Everything with everything else is in equilibrium. Equilibrium means full equilibrium. Anything with anything else. So our interest is where nitrogen gas means, and nitrogen in what standard state will be convenient? 8%. 8% liquid iron Henrian standard state will be convenient. 8% in liquid iron. As we write. And this cannot be N2, but it will be half N2. This equilibrium incidentally considered. Okay, first of the 5 topics, and we showed you why delta G0, how to find delta G0, and many things like why ENN is 0, etc. Anyway, don't worry. So this is the question. Separate. This is the consider the equilibrium. Delta G0 must be given quickly. What is the delta G0? 3598. 3598 plus 23.89 T joule. Happy? Or again delta G0, the temperature under study is 1873. I gave this, but I removed this. Let us write once more. 1873 Kelvin. Sorry, 1873 Kelvin. Temperature is very serious, very important. Temperature, say delta G0 1873 is what value? 483344. 44 is what? I can write the, this gives you the equilibrium constant. Delta G0 is minus RT ln K is 1873 is what value? What value it will be? 0.045. 0.045. You remove this line. is what? Write the expression for equilibrium constant. Again, you know, this is Raoultian. I'm sorry, this is Henrian, and this is Raoultian. Write accordingly. This is Henrian Hn weight percent over partial pressure of nitrogen. This is Raoultian partial, but this is power half because half into. So this you can you can always write equilibrium. This equilibrium is the same equilibrium here. Here in the problem it is equilibrium, in equilibrium. So everything is in equilibrium. This is in equilibrium with this, and this is in turn equilibrium with this, and this also with this, and this also. So this is the whole. This is the ideal of equilibrium. If it is not attained, maybe there is sometimes we call partial equilibrium. Okay, if any of the reaction, any one of them is in equilibrium, is not in equilibrium, or any two, then we say partial equilibrium. Well, but normally by concept is equilibrium. Equilibrium means total equilibrium. All possible reactions are under equilibrium, of which we have picked up this one. This nitrogen and this nitrogen gas. This will help us determine the weight percent nitrogen. What is this? Or HN weight percent is what? How much it is? If we calculate this, HN weight percent is what? 3.46 times 10 to the minus 3. And actually consider this is HN is okay. This HN weight percent is actually this is what this is. We consider weight percent nitrogen. Okay. Fn times weight percent nitrogen. Okay. We consider 1. Okay. Is 1 because ENN is 0. Remember ENN is 0, so it will be 1 actually. And don't worry. Just you write this is weight percent n, and that gives you the answer 3.6. Answer. What is the ppm? You may be interested. Times 10 to the power 4. If you multiply 10 to the power 4 means 34.6 ppm nitrogen. This problem is over. Problem 2 is over. Problem 3 is written here. Oh, sorry. Problem 3 is over. I'm sorry. Problem 4. Okay. Problem 1 last day we solved. Okay. Last class. So problem 4. Okay. Now we pick up problem 4. Okay. So we remove this. Problem 4. Problem. So just wait a minute. Have a break. Let me clean this. Okay. Board now. Clean this. Okay. Clean this board. Okay. It is better I remove this. See, another thing I may do for space, I can remove this also. This problem 2 and 3 over. Problem 2 and 3 over. So now good idea to remove this. So only problem 4 will be kept here, will be saved here. Okay. So I remove this. That's it. Okay. So let us start. Problem 4. We have enough space now. Enough. Okay. Okay. Start. Problem 4, what it says? It says that, let us read this problem. A BOF metallurgist proposes to determine when steel contains 0.04% carbon by analyzing the off gas, means exit gas, off gas for CO2, and assuming no change in off gas composition during sampling, what percentage CO2 indicates 0.04% carbon. Okay, so at 1873 Kelvin, total pressure is 1.3 atmosphere, slightly greater than 1, okay, maybe due to some resistance, okay, in the hood part. And what is the weight percent? Oxygen at 0.04% carbon. This, okay, these two questions are given, and we have to, okay, find the answers. And the same reference, so start here. Oh, solution. What happens here? I don't understand. Sorry, I don't have much time to waste. Solution for problem 4. For problem 4. So let us have a sketch. Bio metallurgist, okay, we say something, okay. So we have to sketch is again what you have. Fe, metal phase, Fe is there, carbon is there, oxygen is there. What is entering here? Oxygen, the typical oxygen gas. Okay, this is actually BOF or OBM, BOF furnace, basic oxygen furnace, BOF or OBM, bottom blown, BOF, OBM process. Okay, then what you have, this is the metal phase, and what you have, there is a slag phase. Slag phase actually just mention that there is a slag phase, that is good enough. And what is living here? CO, CO2, oxygen, exit gas, exit gas contains what? CO, CO2, oxygen, oxygen gas. P total is what? P total is slightly greater than 1.3 atmosphere. Oxygen is negligible as usual, negligible, but mention that negligible. So it is mainly CO, CO2 gas. And this is what else? Temperature is 1873 Kelvin. 1873 Kelvin. Okay, this is very good. So, so let us consider this equilibrium. CO2 gas plus carbon, 1 weight% in liquid iron. This is the standard state. Henrian goes to 2CO gas. This is this delta G0 is what for this? delta G0 is what? 143,972, minus 128.74 T joule. Very good. This gives you delta G0 1873. Why I consider this? What does it mean? Which equilibrium I am considering? Follow. CO2 I picked up, CO and carbon. Why carbon? This right here, this is the which phase? Metal phase. This is the metal phase. Slag metal gas. Why iron? Liquid iron is there because solvent. Carbon will be there because carbon. That's why CO2 is coming or CO is coming. Actually, mainly is CO. But what percentage of CO2 will be present in this? So CO and CO2, since carbon is there and oxygen is going there, CO2 is there. Some oxygen residual unreacted leftover at equilibrium is there, but that is negligible. We may consider this when it is additive term or in the summation term, we will neglect that. But itself CO2, this is called oxygen potential of the gas, this exit gas. Anyway, this we all know. Delta G0 is this. Delta G0. Oh, by the way, somehow actually this delta G 1870 I forgot actually, but I get the answer. This right. You try to find this. Let me show you. 1873. So which I picked up CO2, CO and carbon. This equilibrium. 1873 you find out yourself. That leads to equilibrium constant delta G0 is minus RTLN K. If you do this correctly, you will get K 1873 is 512.46. Now you check this. Now you tell me what you write. Equilibrium constant expression. Next, this part is easy. Expression is what you write. Tell me. P numerator PCO square over PCO2, very easy. And what you write here for Henrian HC weight percent, and you may give in the subscript the equilibrium state. Okay. Now what is the PCO? We have to consider PCO2 in the exit gas of gas. Off gas means exit gas. PCO2 in the off gas is P atmosphere. Let B P atmosphere. Then PCO will be what? PCO will be what here? Okay, CO2 percentage CO2. Okay, very good. What is PC? Time. PCO will be what? PCO will be what? Tell me. PCO plus PCO2 plus PO2. How much total is 1.3? If it is P and if it is negligible, right? Negligible or means small negligible will be justified. Will be justified later. Will be justified later. Always you consider and then show that PO2 is this. So no problem. This is a standard practice. PCO is what? This PCO2 is P. Then PCO will be what? Okay, PCO2 is P or negligible, or PCO is what? PCO is what? This is how much? This is P I have considered. P is nothing but this is negligible. Negligible means 0. 1.3 minus P. 1.3 minus P atmosphere. PCO. Please substitute this. 1.3 minus P squared. PCO2 is how much? P itself. HC weight percent. HC weight percent again here I consider this. HC weight percent is what? Is okay. Very good. 1.3. Continue with this. PHC is what? Right? FC times weight percent C. As you do always, Henrian activity coefficient times weight percent. This is Henrian activity is what? Now here you write this. out log FC now. Now log FC is what? Log FC you have full control. Is tell me what are the things present? ECC self, first of all self carbon plus E other solutes, namely who are they? Oxygen only, 8% oxygen. But this is still PO2 is negligible, 8% oxygen is also negligible. This is to be, shall I consider this? Okay, but oxygen is negligible, small actually, negligible, negligible. But anyway, we will find this. But this is to be found. This is to be found at the end. We will justify this, that this is negligible or negligibly small, negligibly small. So ignore this compared to this term. ECC is how much? ECC is how much? Tell me number of times you are using ECC 0.22. 0.22. 8% carbon is what? That is our interest. What is the 8% carbon? This whole issue is on 0.04% carbon. We have to predict which PCO2. What is the question is? What percentage CO2 corresponds to what? 0.04% carbon. So what is the percentage CO2 here that corresponds to 0.04% carbon? So this is the equilibrium situation. So these are all equilibrium terms. Okay. So what is this? 0.04. These are all this is equilibrium term. It's equilibrium. So this is actually 0.04. So what you are getting out of this? 0.088. This is negligible, means this is 0. Or FC is what? FC is important. FC will be, if you do this 0.088, 0.088 is correct. No, still another 0. 0.0088. I'm sorry. 0.0088 or 8.88 times, or FC will be very small, close to 0. Close to 0, the FC will be 1 almost. Actually, it will be 1.02. If it is 0, it is 1. So 1.02. So 1.02 you will put back where? Where? Here. So you can take from this point. From this point where? From this point is, continue, 5, write this, 512.46 is 1.3 minus P squared. Here copy, P, copy, FC 1.02, 8% carbon. That is our interest. When it is corresponding to this carbon, what is the percentage shift? This is the question. So you have only one quadratic equation in P. Quadratic equation, shall I write this? Or P is okay, very good. Or P is, if you do this quadratic equation, if you get this, P will be what? 23.51. This will get quadratic plus minus 23.36 perhaps. 23.36 by 2. See, plus cannot be accepted because it gives you 23 atmosphere. Total pressure is 1.3. Absurd. So minus means 0.15. 0.15 divided by 2 means 0.075. P. This is your atmosphere, or P is 0.075. Hence, what is the P? PCO2. So hence PCO2 in the exit gas, in the exit gas, in off gas is how much? 0.075 atmosphere. But what is the percentage is question? What is the and what is the PCO2 is this much? What is the PCO? PCO will be what from this? 1.3 minus 0.075. How much it is? 1.27, 225. 1.225 atmosphere. Okay, so both are obtained. This is also in the off gas, both off gas. Okay, fine, very good. Then what is the percentage CO2? This leads to here. This space, utilize this space. Percentage CO2 which is required. Tell me what is nothing but these two are main component. Oxygen is negligible. That we will show this is to be justified. These two things is PO2 will find out soon. This will be justified later. But let me finish this percentage CO2. Given this, the exit gas contains only mainly CO and CO2. So what is this? What is the percentage CO2? Is nothing but PCO2 over PCO plus PCO2. That is mole fraction times 100. What is this value? 0.075 plus this together is 1.3 times 100 is what percentage it is. If you do this correctly, 5.77%. This is your answer. What percentage CO indicates? Carbon is 0.04. This percentage. That you get from the off gas analysis. This is actually when you get this value of CO2 in the off gas, then you understand the carbon is in the metal phase has been 0.04. So this part is now quickly two small jobs to show that PO2 is negligible. We guess that it will be negligible, and also 8% oxygen is negligible. For these two separate equilibrium will be considered first of all. Now to show next additional points. Okay, to show answer this is over. To show PO2 negligible. To show the PO2 is negligibly small. What you will consider? What you will consider? Tell me. So what is this for this purpose? Half O2 gas goes to oxygen 8%. What is this? Question is where 0.04% carbon. I forgot this. In the exit gas. In the off gas. Off gas means exit gas. I am sorry. You consider the equilibrium. Consider the equilibrium. CO gas plus half O2 gas is CO2. Okay, let me change the pen. CO gas plus no, this is not doing very well. Oh, this has dried actually, dried up. But anyway, this will be good enough. Right here, CO gas plus half O2 gas is CO2 gas. This is very simple. What in fact you are asked what is the oxygen potential of this gas mixture? Same question. To find the PO2 equilibrium. So strike this equilibrium. So CO2 is there and strike the equilibrium with involving oxygen. So CO plus naturally delta G0 is what? Standard delta G0 is right. This CO plus half O2 is CO2. Very minus 280956 minus 280956 plus 85.23 T E joule. Happy? Or you get again delta G0 as usual. Hot temperature 1873. How much it will be? Quickly. Delta G0 1873 is what? Okay. This is okay. You find this and this leads to K 1873, which is actually 2418. 2418.4 is what? PCO2 over PCO times PO2 power half equilibrium. Consider this CO2 O2. This gas is also an equilibrium by itself in equilibrium with respect to CO2 and O2. O2 is very small, that we will see. Okay, CO2 is how much? PCO2 already found. How much? 0.075. PCO found 1.225. This gives you, I give a star here. I'm writing this side, here, this side, or PO2. Actually, you can write equilibrium is what? What value PO2 equilibrium is? 6.4 times 10 to the power minus 10 atmosphere. This is the PO2 equilibrium. So negligible. See, now see, it is justified. Hence justified. Hence, that is negligibly small. Negligibly small. Also, at the same time, note here that this is the oxygen potential of the gas. Note in passing, small, very small, but that is the oxygen. Okay, very small value. Note in passing, this is the oxygen potential of the exit gas mixture. Time? 1 hour 41 minutes. Okay. Of the exit gas mixture. Exit gas. This is not required actually. This I say in passing. Okay, PO2 equilibrium. So negligible you here. Then another is what? Weight % oxygen. Since this is negligible, corresponding oxygen. See, oxygen comes from where? This oxygen. Okay, corresponding oxygen here. Equilibrium. This oxygen and this O in equilibrium. So consider that. Okay, again, any with any. So can I remove the first line only? First two lines maybe. Then we will get this. So what equilibrium concerned? Lastly, to show weight % oxygen is also negligibly small. Actually, oxygen, this is in equilibrium. Weight % oxygen and PO2 and oxygen, yes, oxygen gas in equilibrium. So if one is small, another is small. So how? Let us write the equilibrium, you will understand. To show the oil is also in equilibrium, negligibly small. To show that, consider the equilibrium. Pertinent equilibrium is what? Between oxygen gas and weight % oxygen. Obviously, it will be O2 gas and oxygen in 1 weight % in liquid iron, Henrian standard state. And this cannot be O2, but half O2. So quickly, delta G0. Already I am giving data is given quickly. Half O2 is what? Minus 111 triple 1 300 minus 6.41 T joule. This gives you K delta G0 1873. First of all, you calculate which. So I don't have correctly. K I calculated. Give the result. K 1873 is what? 2747. Can I remove all this? So 2747 is what? Again apply. Equilibrium constant is what? This is HO weight %. Attach this, and then it is PO2 power half. Again, if necessary, write equilibrium. Sometimes even in books you will see this is not written. Okay, but it is better you write this, or if you understand, then fine also. Okay, HO is what? Tell me. HO is what? You tell me. HO is FO times weight %. You just see FO times weight % O. over PO2 is how much? PO2 a moment ago, PO2 a moment ago. 6.4 times 10 to the power minus 10 power half. This PO2 equilibrium, this is here. This equilibrium with this. See, follow, see the equilibrium. This in equilibrium. So whole system is in equilibrium. This leaving exiting gas is when it exits, before that it has attained equilibrium with the slag and the liquid metal. Any component you can consider. So what you consider here, I tell you quickly, if possible, you consider oxygen O. You consider this. You consider CO, CO2C. Didn't you previously? See, also you consider this the exit gas only alone. This gas, who CO2 CO2 equilibrium. So understand. So this is actually, if you have this, no problem. Quickly delta G0 is okay. FO 8%. What is this? Log FO is what here? To find FO, log FO. Log FO is what? EOO, self first of all, plus who else? Who else? Or other solute? Carbon only. Carbon. Here no silicon. Here, okay, in this problem at least. Iron, carbon, oxygen. Iron cannot be. These are all solute. Okay. Effect. Okay. Solutes on the activity coefficient of any chosen solute. Okay. This is self because effect of oxygen on oxygen. This is a carbon. 8% carbon. Okay. EOC plus O2. Okay. Of which 8% oxygen again. What is? Oh, 8 plus oxygen we are going to find out. So I consider this. I consider somewhere else also, but anyway, negligible to justify later, means now actually after this. So this is negligible. If it is negligible, the whole thing is 0, negligible. So what remains is EOC is for minus 0.3 perhaps, 0.13. This is what? Minus 0.03. This interaction coefficient minus 0.13, right? Minus 0.13 8% carbon. So what you are getting from this? Log FO minus, what is the 8% carbon? You know, from the very beginning, you know what is the value? 0.04. 0.04. What you get of this? Minus 0.0052. Minus 0.0052 or very close to 0, or FO is how much? Log FO this. This close to 0 means FO is 1, but exactly this is 0.99. 0.99 is actually 1. So you could have neglected this. So if you substitute this 1, approximately 1. So what is this is known? Actually 1 is just, since I have already said that this is 1. Put 1. So you know this, you know this, you know this, you don't know this. What is this? Or 8% oxygen is how much? You write, calculate out. 8% oxygen is 0.07. This is also asked. What is the 8%? What is the, see, read, what is the 8% oxygen at this 0.04% carbon? When the carbon is 0.04%, then what is the percentage oxygen? 8% oxygen here. So it is what? You have to find. This is the 0.07. 0.07 means what? 0.0 answer. This is the answer. Second answer. This is the second answer. First answer was the pressure is, you have mentioned what is the percentage of CO2. You got the answer 5.77%. This answer you have given, and now you have given 8% oxygen, which is 0.07%. This also means how much ppm? Times 10 to the power 4. So 700. That is, since it is small, I am giving you 700 ppm. Okay. So this part is also. So what is it? So justified 8% oxygen we consider negligible. So 0.07 it is actually not large, it is negligible. Okay, so that's why this is justified. Okay, so this is weight percent oxygen, so justified. So this so negligibly small. Achha, this I am not writing because I have already written, because since this is the answer, so I should write actually 0.07 this answer. But okay, here it is mentioned this and weight percent oxygen this. Okay, if you don't ignore, then it will be only complicated. This you have to solve. Actually, what is this called? This will be log FO weight percent. So this will be actually, if you don't know, so it is weight percent oxygen, then this will be a non-linear equation, and you have to little bit more difficult. Nothing else. It can be solved. Okay, you can always solve. But this is how we actually handle these small values. In the plus terms, then so later, yes, it is small. So there is no class. There is no okay conflict there. Okay, thank you. This is over. Next is problem what? Problem 5. Problem 5. I have not written. I am writing now. Problem 5. I should write here on the right hand side. Wait a bit. Wait a bit. Particularly this place I write. This side. This side I will write problem 5. Then total 9 problems. So 4 problems. 4 problems over time. 1 hour 52 minutes. 8 minutes. Okay, just let me write the problem at least before. So this is our problem 5. 8 minutes, right? You come just at time, right time. Problem 5. Problem 5 is what? A BOF steel was what is this called? Is blown with oxygen. Is blown with oxygen to 0.06% carbon. Temperature is 1600 degrees centigrade. The typical steel making temperature. Subsequently, the steel is to be deoxidized. The steel is to be deoxidized to a residual 0.015% residual oxygen. O means oxygen. Oxygen by adding silicon metal. By adding silicon metal. The deoxidation product is SiO2 solid. This is solid actually. Why it is solid? It's pure silica. Its melting point is about 1720 degrees centigrade, and this temperature is, oh, I'm sorry. Yes, right. Its melting point is greater than this, so it will not be molten. Actually, it is molten in steel making. Why? Because presence of flux, and the very important flux is lime. So calcium oxide silica has a lower melting point than 1600 degrees centigrade, and also others are there. P2O5 is there, APO is there. So, but here you have to consider when you give a problem, sometimes we simplify the problem, but if you can solve this problem, you can solve more complicated problem, because activity of silica will be there. You have to consider instead of solid, you have to consider liquid, and activity should be given. You have to you must know, and that's this you solved previously. Anyway, this is silica solid. Okay, how many kg of silic, silicon needs to be added needs to be added per ton of steel to attain this level of deoxidation. This is the question. Okay, temperature remains at 1600 degrees centigrade. This is a typical steel making temperature, 1873 Kelvin. Again, reference A. Morris. Yeah, please check this. Okay, as I already said, I'm a 90% sure, but still to check. Okay, let us solve this solution. Bob, how much time is left there? Acha, solution. Solution. Problem 5. Problem 5. What is the first of all you consider? First to find C weight percent in short. 1 weight percent liquid iron, I am not writing short, plus oxygen weight percent in short is CO gas. Find CO gas, find the delta G0 for. This is the first task that we will do. For this, how? Giving data apply, data given. C weight percent, if you write 1 weight percent in liquid iron, or in short, just weight percent will be good enough. We'll understand that it is 1 weight percent in liquid iron. Short also will do, plus half O2 gas, plus half O2 gas is CO gas. This delta G0 is what? How much? Is minus 136,984 plus minus 43.51 T joule. And also consider oxygen 1 weight% in liquid iron goes to half O2 gas. This delta G0 is how much? 111,300 plus 6.41 T joule. You combine this, you'll see this and this you cancel. See, you combine this and this you cancel. That's very easy. Addition will do. Plus you'll do here. Okay, what you'll get? Carbon. Just I'm writing in short. Means 1 weight%. This means 1 weight% in liquid iron. Okay, so carbon weight%. What are this cancel plus oxygen weight%. Means this term goes to CO gas. What is the resulting delta G0? If we add this, is this minus 25684 minus 37.1 T joule. Okay, what is or again you get hello. Good. Really? Huh?
2 hours only.
Oh, because it's okay to both are okay.
No, that is not.
তবে ঘুমাচ্ছিলি কেন? তুই তো খাস হ্যাঁ আমি তো লোক তুই এই তো বল দেখলি তো 7 minutes or 6 minutes or 5 minutes.
আমি তো 10 মিনিটে ইয়ে করে রেখেছি তো দুটো 2 পর্যন্ত তো চলে তো তো সেই টাইম করে করে দিয়েছি।
ওকে ডেল্টা G0 দেখি যা এইটা করে দিন একটুখানি 1 সেকেন্ড 1870 তে বেশি মাল লাগবে না 1870 goes is okay this leads to K 1870